Today, we're turning our gaze towards Earth's oceans, but from a unique perspective, space. Explore the satellites that have been launched for the first time aimed at studying our vast and mysterious oceans. We know that a satellite is an object that orbits around a planet, moon, or other celestial body in space. A sensor or instrument, in the context of satellites and technology, is a device that detects and measures physical properties or environmental conditions. Therefore, satellites are a general term and the sensor mounted on them is used to collect data. Satellites may be fitted with many different sensors that collect data. Satellites collect data from the ocean using a variety of sensors and instruments that are designed to measure different aspects of the marine environment. These satellites are equipped with specialized remote sensing technologies that allow them to gather information about the Earth's oceans from space. There are two general categories of satellites, passive and active. Many oceanographic measurements are made using passive remote sensing. In passive remote sensing, satellite sensors detect natural emissions of energy, such as sunlight reflected off the ocean's surface or thermal radiation, without actively sending out any signals. Some ocean data is collected through active remote sensing. In this method, satellites emit signals, such as radar or microwave pulses, toward the ocean surface and then measure the return signal. This can be used to gather information about sea surface height, wave height, and ocean currents. Oceanic satellites are typically located in a specific type of orbit known as a polar orbit. A polar orbit is an orbit that goes over the Earth's poles, passing nearly perpendicular to the equator on each orbit. This type of orbit is well suited for observing the entire planet's surface, including the oceans, as the Earth rotates beneath the satellite. Oceanic satellites are typically located in low Earth orbit, LEO, which is relatively close to the Earth's surface compared to other types of orbits. The altitude of satellites in LEO can vary, but they generally orbit at altitudes ranging from about 160 kilometers, 100 miles, to around 2,000 kilometers, 1,240 miles, above the Earth's surface. For oceanic satellites specifically, altitudes in the range of 500 to 1,000 kilometers, 310 to 620 miles, are common. This altitude range allows these satellites to provide good spatial resolution for ocean observations while still maintaining relatively frequent coverage of the Earth's surface. The quantities of temperature, salinity, and ocean surface height play an important role in oceanography. We can determine the density of water from the existing equation based on temperature and salinity. Sea surface height refers to the distance between the ocean's surface and a reference point, usually the Earth's geoid, a hypothetical surface that closely approximates mean sea level. It is an important parameter used to understand ocean dynamics, ocean currents, tides, and even changes in the Earth's gravity field. For this reason, it is important for oceanographers to have density and dynamic height in order to obtain ocean currents using the equations. Let us now examine what the first satellites launched into space to measure temperature, salinity, and sea surface height. The first satellite launched to space to calculate ocean surface temperature was the Nimbus 3 satellite, specifically its Advanced Very High Resolution Radiometer (AVHRR) instrument. Nimbus 3 was launched on April 14, 1969, by NASA. The AVHRR instrument was designed to measure infrared radiation emitted by the Earth's surface, including the oceans, which allowed scientists to estimate sea surface temperatures. The AVHRR instrument could detect thermal infrared radiation emitted by the Earth's surface and measure its intensity at different wavelengths. This information was then used to calculate the temperature of the ocean's surface. While the technology and resolution of the AVHRR instrument were relatively basic compared to modern instruments, it marked a significant step in remote sensing of the Earth's oceans from space. The first satellite specifically launched to measure sea surface height was the SEAS-AT-1 satellite. SEASAT-1 was launched on June 27, 1978, by NASA, and it marked the first satellite mission dedicated to ocean observations. SEASAT-1 carried a radar altimeter called the Radar Altimeter System, RAS, which was designed to measure the distance between the satellite and the ocean's surface using radar pulses. The altimeter emitted radar signals that bounced off the ocean surface and were then received by the satellite. By measuring the time it took for the signals to travel to the ocean surface and back, the satellite could calculate the sea surface height with remarkable accuracy. The first satellite specifically launched to measure ocean surface salinity was the European Space Agency's ESA, Soil Moisture and Ocean Salinity, SMOS, satellite. SMOS was launched on November 2, 2009, with the primary goal of providing global measurements of soil moisture and ocean salinity. SMOS carries a specialized instrument known as the microwave imaging radiometer using aperture synthesis, MIRAS. This instrument operates in the microwave frequency range and uses radiometry to measure natural microwave emissions from the Earth's surface, including the oceans. By analyzing microwave emissions, SMOS can derive information about the salinity of the ocean surface. The first satellites launched to study the oceans were these. Stay updated and engaged. Subscribe to our YouTube channel.